Dear students, I would like to present to you an important theorem regarding the central moments of the normal distribution. As you know, when I say central moments, it means the moments about the mean. So the theorem is as follows. For the normal distribution, the odd order moments about the mean are all equal to 0, and the even order moments are given by mu 2n, where 2n, of course, is in the subscript, is equal to 2n minus 1 into 2n minus 3 into 2n minus 5, and so on, until we reach 5 into 3 into 1, and this whole thing multiplied by sigma raised to 2n. N itself is a positive integer. For example, if n is equal to 1, then 2n is equal to 2 into 1, and that is equal to 2. So that particular moment will be mu 2, the second moment about the mean. If n itself is equal to 2, then 2n is equal to 2 into 2, and that is equal to 4. So that particular moment will be mu 4, the fourth moment about the mean, and so on. अब ये जो मैंने थ्योरम आपके सामने रखा है, let us do and try to prove it step by step by step. Let's begin with the odd order moments. By definition, the odd order moments can be written as follows. Mu 2n plus 1. अब अभी मैं explain करूंगी कि why have I taken this subscript as 2n plus 1. But if it is this, then it is equal to the expected value of x minus mu whole raised to 2n plus 1. Obviously, क्योंकि अगर subscript r हो, rth moment, तो हम यही लिखते हैं ना कि it is the expected value of x minus mu whole raised to r. So before I do the next step, I would like to explain this right now कि हमने उसका subscript r जो है उसको हमने 2n plus 1 क्यों लिखा है. उसकी वजह एग्जैक्टली वही है या बहुत ज़्यादा करीब है उसके कि जो मैंने अभी आपके सामने रखा कि n itself is positive integer. So for example, in fact n can also be 0. अगर आप इसमें पहले n को 0 रखें तो 2n plus 1 क्या होगा? 2 into 0 plus 1 यानी 0 plus 1 यानी 1. So mu 1 हम इस वक्त odd order moment चाह रहे हैं, तो हमें mu 1, mu 3, mu 5 यही चाहिए. So अभी देखिए कि अगर n 0 हो तो 2n plus 1 is 1. So that's the first moment about the mean. अगर n 2 रखें तो क्या होगा? अगर n 1 रखें तब क्या होगा? 2n plus 1 is 2 into 1 plus 1. So that is 2 plus 1, and that is equal to 3. तो वो जो आपको अगला चाहिए था odd order moment mu 3 वो आपको मिल गया. इसी तरह you can go on and you can find that this expression does indeed yield the odd order moments. All right, so now let's do the derivation. The expected value of x minus mu whole raised to 2n plus 1 is obviously equal to the integral from minus infinity to infinity of x minus mu raised to 2n plus 1 into the PDF of the normal distribution, that is 1 over sigma under root 2 pi into e raised to minus half x minus mu over sigma whole square. अब इसके अंदर we do the same transformation that we do for so many other proofs of other theorems. And what is that? We let z equal to x minus mu over sigma, implying that sigma z is equal to x minus mu, or x is equal to mu plus sigma z, वो भी आप लिख सकते हैं. इनफैक्ट यहाँ पे आपको उसकी ज़रूरत नहीं, बिकॉज आपके सामने इंटीग्रल के अंदर जो पहली चीज़ लिखी हुई है दैट इज x माइनस म्यू होल रेज टू 2n+1, और यहाँ पे ये जो सिग्मा z इक्वल टू x माइनस म्यू आ गया है, तो वहाँ पे उस वक्त जब हम वहाँ पे पुट करेंगे वी विल सिंपली राइट सिग्मा z. दूसरी चीज़ साथ ही ऑफ कोर्स वी हैव टू सी कि dx जो लिखा हुआ है पहले एक्सप्रेशन में वो अब कैसे लिखा जाएगा. तो ये जो ट्रांसफॉर्मेशन है इसके तहत dx by dz is equal to sigma, implying that sigma dz is equal to dx. The other important thing is that the limits remain unchanged as x tends to minus infinity, z tends to minus infinity minus mu over sigma, where sigma is a positive number. Therefore, we can say that z also tends to minus infinity. Similarly, when x tends to plus infinity, z tends to plus infinity. Therefore, as I said, the limits remain unchanged. And then, substituting all these things, what do we get? Mu 2n+1, yani 2n+1th moment about the mean, is equal to the integral from minus infinity to infinity, sigma z whole raised to 2n+1 into 1 over sigma square root of 2 pi e raised to minus half z square, क्योंकि वहाँ जो था x माइनस म्यू ओवर सिग्मा, वहाँ पे अब आप z डाल रहे हैं, और आगे जो dx लिखा हुआ था उसकी जगह पे सिग्मा dz. इसमें जो सिग्मा कैंसिल हो रहा है न्यूमरेटर के अंदर, उसको यानी न्यूमरेटर वाला जो है उसको कैंसिल कर दें with the 1 in the denominator, and then what do you get? Sigma raised to 2n+1 over square root of 2 pi. This comes outside the integral. और इंटीग्रल के अंदर जो इसके साथ अटैच्ड है, what do we have? The integral from minus infinity to infinity, z raised to 2n+1 e raised to minus half z square. तो students, ये जो है, this is an odd function of z. Which one? Z raised to 2n+1 into e raised to minus z square over 2. क्योंकि odd function क्या होता है कि अगर आप z की जगह माइनस z पुट कर दें तो वो जो एक्सप्रेशन है उस पूरे एक्सप्रेशन के साथ एक माइनस अटैच हो जाए. यहाँ पे देख लीजिए, अगर आप z स्क्वायर वो जो पावर के अंदर है वहाँ माइनस z रख देंगे तो इट विल स्टिल बी इक्वल टू z स्क्वायर. लेकिन शुरू में जो z रेज टू 2n+1 है वहाँ पे अगर आप माइनस z रेज टू 2n+1 करेंगे तो चूंकि वो 2n+1 एक ऑड नंबर है, चाहे n को कुछ भी रखें, इसलिए माइनस z raised to an odd number, for example if it is 3, so minus z raised to 3 is equal to what? Minus z raised to 3. तो इसलिए because it is an odd function, we can apply the simple rule that the integral of an odd function from minus infinity to infinity, or from minus a to a, where a can be any number, is equal to 0. So therefore, what is the final result? Mu 2n+1 is equal to sigma raised to 2n+1 over square root of 2 pi into 0, and that is equal to 0. So that is why we say that all odd order moments of the normal distribution are equal to 0. Isn't that remarkable? Mu1 equal to mu3 equal to mu5 equal to so on equal to mu27. This brings us to the end of the first part of the theorem, and we have proved that the odd order moments of the normal distribution are 0. And for the other part, we will have a long derivation separately.